Here's the last question in this section. You have done this type of problem many times. So let's take a look at this. So a ball is thrown upward with this initial speed. So therefore you should interpret this as v sub 0 equals 48 feet per second. From the edge of a cliff, 432 feet above. So this will be your initial position, which is S0 is 432. The acceleration of the object under gravity is about negative 32 feet per second square. Or if you use the meter per second square as the units, it will be about negative 9.8. Because we are given the feet and feet per second, so I would like to stick with the feet per second square. This is what we would use. Now let's try to solve the problem by, first of all, we do know the under the gravity the acceleration is this guy, so which means a of t will be equal to negative 32 feet per second. So which per second square, I'm sorry. So which means v of t, which is the antiderivative of the acceleration, is going to be finding the antiderivative of negative 32, which gives us negative 32 t plus, say, c1. Now, because we do know v of 0 is 48, plug this into this equation. It gives us c1 is equal to 48. Therefore, we do know the velocity function is equal to negative 32 t plus 48. Let's find the position function. It's the antiderivative of the velocity. So we're gonna integrate the velocity function, which gives us, this will be negative 16t squared plus 48t plus another constant, say call it c2. And because we do know the initial position is 432 feet above the ground, so that means this guy. So we plug in S0, which gives us C2, right? Because when you plug in 0, this is 0, this is 0. You're left with C2. And this is equal to the initial position, 432. Therefore, we now know S of t is equal to negative 16t squared plus 48t plus 432. So that's how we find the position function and velocity function. I actually would like to encourage you to create some questions for your peers to solve that's related to the position and velocity. You can pause my video for a moment because I would actually share a few thoughts with you here. So one problem you can ask is, say, when does the ball reach its maximum height, right? So this is one sample problem you can ask. Or sometimes you can ask, when does it hit the ground? Or you can also ask, hey, when it hits the ground, at what velocity does it hit the ground? So there are a whole bunch of questions that you can ask. So how would you answer the maximum height? You probably that occurs when velocity is equal to 0, right? When velocity is equal to 0, so you set velocity to 0 and then find the time. So that will be when the ball reach its maximum height. So when does it hit the ground? Basically, that's when the position is equal to 0. So then solve for the time. And at what velocity does it hit the ground? Once you find when the ball hits the ground, you know the time, then you can use the velocity function, plug in this time, then you know the velocity when the ball hits the ground. So these are the problems that we actually we did those problems back in an earlier chapter. So that's it for this chapter.